Okay, so in triangle CHR, there is certain information given. Read it carefully, because if you suspect that this might be from the unit of similarity, you need proof that it's actually a similarity kind of a question. So whether they told you in the given the two triangles are similar, or you look for information that allows you to establish the fact that the triangles you observe are similar. And how could you do that? You could do that by seeing if whether one of these rules can prove the triangle similar. And sure enough, if we mark this piece of information and notice the piece of given, unmentioned piece of given right here, angle R shared by reflexive, then you have two pairs of angles, and therefore the two triangles, the small one right here and the giant one, are similar. Notice that marked in red pair of angles is not situated traditionally as we used to seeing it in the case of a triangle with a split side. We normally would see these two angles in the position of corresponding pair, so we know they are congruent. In a situation given, the two angles are not corresponding, which indicates that when you write your proportions, you will have to be extra careful. Probably is not a good idea to be looking at the diagram to pick the corresponding sides. You definitely will benefit from having a correspondence statement for similar triangles written out. So that will be your next objective. You will write the statement showing corresponding vertices, and then using that statement will write the ratio of corresponding sides and proceed with substitution. So according to this diagram, if I name the original triangle CHR as they recommend, then I should notice from my given information angle C has no marking, therefore it will correspond with angle O, who also has no marking. Angle H right here would be then corresponding with angle that is set congruent to it, RDO, right here. And angle R is itself by reflexive property. Therefore, it allows me to write the ratio, and I will start it with the triangle in green to be on top. So I'm taking two letters at a time, vertices CH over two vertices that are also in the first position, and I will complete the rest of them the same way. So as I follow up with substitution, for that I will need the rest of the information from my text. Notice as I mark the info about lengths, I use brackets because it's very easy to confuse them in that case. And then it will be easy to substitute the values. Just make sure that for CR, you have the length that is a sum of x and 4, and that sum is in parentheses. So as you solve this equation, which you could do by the product of means and extremes, you will find the value of x. And of course, according to your diagram, the value of x actually is the CD. Therefore, your answer to this problem is CD equals 11. Next question. Pause the video to make yourself familiar with it and complete the markings if necessary, which would mean that we have perpendicularity right here, which makes triangle ACB the right triangle. Special case because now you have altitude drawn in it, which automatically in your mind should bring you to two possibilities. They either are checking the rule of leg is a mean proportional between projection and hypotenuse, or altitude CD is mean proportional between hypotenuse part 1 and hypotenuse part 2. based on the information I have on the diagram now, it's not clear which rule to use. That is because I never put the question itself. What is the length of AC on the diagram? Now I did, and clearly it's a leg of the big triangle that's given. Notice, in this kind of questions, you always want to see, do they give you an altitude or do they give you a leg? And there would be two possibilities for legs, because these are the two facts that determine which of the two rules you will be using now. Well, based on the fact that CD is something I need to find, I will be able to write a rule that refers to a leg of a right triangle where the altitude is drawn. So that's actually this rule. I will now complete the substitution. It's easiest to complete the mean proportional, the leg itself, which in our case is AC. Here it is. And then that mean proportional is between projection of the leg onto the hypotenuse and the hypotenuse itself. So you could have AB written in this place and AD written in this place. What is important is that they are one on top, one on the bottom, on both sides. By the way, convenient way to remember this rule is this visual mnemonic. If you have a leg, then it will be its projection and the hypotenuse. Or if you have the other leg, it will be projection of that leg and the whole hypotenuse. So once you figure out which rule you're using, the rest is just substitution. Just be careful. In this case, the numbers are pretty straightforward. You see both of the parts, so you could easily tell it's 10. And now by a cross product, you multiply that 10 by 4 to get your AC squared. So it's a quadratic equation where you are solving for AC, who now S squared is 40. So you have to simplify this perfect, well, not perfect square number by finding greatest perfect square number divisor, which is 4. Then remembering how we simplify it and finding the result as 2 roots of 10. And that's the answer right here. I will use the same kind of a question to modify it just a little bit. You could see that I've made some changes. I will now mark these changes on the diagram. AB actually happens to be the entire hypotenuse of the original biggest right triangle. The value is 6. I'm looking for the length of CD. Remember I've mentioned it earlier that you need to see if an altitude is given versus two legs. So in this case, we see that the altitude of a right triangle is given. So out of these two rules, you now will be using the one about the altitude, where altitude is a mean proportional. So CD is written in the place of a mean proportional, and the other two terms of the fractions in your proportion would be one part and the other part formed on the hypotenuse. Now, when you do the substitution, be mindful of the possibility of the information not given in a straightforward way. I see one of the parts is 4, but the other one is not 4 and not 6. It's actually the difference between them. So when you simplify this proportion 4 times the difference of 6 and 4, that produces the result of 8. So square root of the 8 will be CD itself. You just have to simplify it properly. Square root of 4 becomes the 2, still multiplied by square root of 2. Next question is about a directed line segment, keywords, that some point P breaks in a ratio 1 to 5, but they tell you that the division happens in the direction from point X to Y. So let's first visualize it. So if you had a segment XY, then in the direction from X to Y, point P will lie in a way that it breaks the whole segment in this ratio. That's what the main idea is. So I'm going to plot that segment first. And once again, I will reestablish that from X in the direction of Y, I will break it approximately in a 1 to 5 ratio. So what does it mean? It means that the entire length right here, which is, by the way, a sum of this segment and that segment, will be 1x and 5x. That is the entire length. So I have 6 parts altogether. I'm going to use the fact that if I recreate a right triangle, then I will be able to break in the same ratio all other lengths. There are two sides of that triangle. And using those sides, I will find, by projecting the point P sort of on each of them onto the original, I will find the location of the new point. So I will start working with the horizontal segment. I completed the horizontal segment of my triangle right here, counted the number of units, and I'm going to reiterate the fact that if one part is x, then I also have 5 parts. Altogether, these 6 parts should be the length of 12 units. This time, I can find that length for sure because the segment is horizontal. I will be able to do the same for vertical segment. But I cannot say for sure what the length is here that easily for a slanted segment. So from this equation, I can find how big x is. In other words, how big one part is on my segment. And that would be 2 units. So on my horizontal segment, I will mark 2 unit spaces. Now everybody can see 1, 2, 3, 4, 5, 6 units, as we knew there would be. And in the direction from X to Y, that would mean that one part is exactly right here and 5 parts is exactly right here. I now can project it onto the original. This is where the estimated position of real point P would be. I will just verify that with the process for the vertical side of the triangle. So I'm gonna do the same thing, complete the vertical side. It will be broken in the ratio 1 to 5. So again, there will be 6 parts there. I counted the number of units. There will be 9 altogether. So I could know now how big is each unit. 1.5, not a whole number, but nothing unusual. And now we'll be able to tell them 5 units is 7.5 boxes long. So in the direction from X, which is on the bottom, to Y, I will mark off 1 unit. So 1.5, it's right here, right here. This would be my 1. And this is what's left. 5 of those. Altogether, 6 units. And I am going to, as neatly as I can, project that point onto my original segment, just to verify that previous position indeed indicates what coordinates of point P would be. I'll just have to be very careful reading it off the whole plot For x, I'm moving -4. And then for y, I'm moving -half of the unit. And that is the answer to our question. Okay, so we have a triangle ABC. Using a compass and straight edge, which I will not be able to do here, I will construct and label triangle GPS. So I know A would correspond with point G, B will correspond with P, and S with C. After reflection in a line. So what you have to remember is that reflection is basically visualizing the rays of light that coming down at the line of reflection at the right angle. So here is my line of sight. Here is my other line of sight. And the B would have a line of sight. I would have to continue line M. I'll just reiterate the fact that this has to be perpendicular to the mirror itself. The lines of sight are perpendicular. And what we want to do is show that betweenness on the other side actually is the same as betweenness on the original. So I'm going to use these elements clone to find exactly where the corresponding point would be. You will have to do that with the compass. And then I will have to very carefully name the new points. So I know point C, supposed to be C prime, but they want us to label it as S. This distance is the same as this distance. Point A prime, they want us to mark it as G. And point B prime, they want us marked as P. Right here. And then, of course, we will need to connect the 3 points to form the figure itself. And just for fun, let's see what orientation would be. If I go in the order from A to B to C, that's counterclockwise, then GPS would be the order, the clockwise order, which means orientation changed. Now, they wanted to explain why the original and its image are congruent. So we know reflection in a line is a rigid motion. That means that it preserves the lengths of corresponding sides. That is why by 3 pairs of congruent corresponding sides rule makes the 2 triangles congruent. So let me just make sure that I marked these corresponding betweennesses congruent. Of course, then this length would be same as this one, and this one would be congruent to that one. And whatever you have as construction mark after using your compasses should remain on this diagram.